A dying machine is surviving by spinning harder in the dark. Most people think deep space kills you with cold or distance, but Voyager 1 is being threatened by something much smaller. Stay with me because this story is not about a monster outside the solar system, but a whisper inside an old spacecraft. And before we go farther, subscribe if you want the space stories that keep unfolding long after the headlines fade. Right now, the farthest thing humans have ever built is facing the one kind of failure NASA never wanted to see. Not a grand explosion, not an alien signal, not a crash into some unseen rock, just the slow loss of its ability to keep looking home like a tired eye that cannot stay open. And that is terrifying because Voyager 1 survives only if it can keep one thin beam pointed at Earth. Picture a machine smaller than a car, older than many grandparents, flying through black silence more than 15 billion miles away. Its signal is so faint that by the time it reaches us, it is less like a shout and more like a breath on glass. Yet for nearly half a century, that breath has carried news from places no human will see in person for a very long time. Now that breath is getting harder to hold steady. And the strangest part is this. Voyager 1 was never meant to live this long, never meant to teach us this much, and never meant to die this way. And the mission was supposed to be a quick visit to giant planets, a fast road trip, not a lifetime wandering between the stars. Instead, it became our oldest scout, our smallest lighthouse, and maybe our most stubborn messenger. Now let us start from the beginning. A lot of people think Voyager 1 is already drifting dead through space, like a museum piece with its lights off. That is wrong. Voyager 1 is still working, still sending data, and still forcing engineers to make hard choices almost day by day. Another common mistake is thinking interstellar space means the mission is basically over. It sounds like the end of a map, as if there is nothing left but blank paper, but crossing into interstellar space did not end Voyager's story. It began the most surprising chapter, and it also raised the danger of losing the probe when its work became most valuable. Voyager 1 launched on September 5th, 1977 at 12:56:01 Universal Time. It left Earth after Voyager 2, but it took a faster path and passed its twin on December 15th, 1977. Back then, nobody at NASA expected people in the 2020s to still be waiting for its next signal. The mission was built for a few years, not for the length of a family mortgage. This is the underdog part people forget. Voyager 1 does not run on modern chips, smart software, or fresh hardware pulled from a clean box. Suzanne Dodd at NASA's Jet Propulsion Laboratory once pointed out that even the button on your car key has more computing power. That is like learning a kitchen timer is somehow outthinking a whole spaceship. The spacecraft first dazzled everyone at Jupiter in 1979, and then it reached Saturn in late 1980 and helped show us rings, moons, storms, and a hazy Titan hiding its surface. That alone would have made it a legend. Instead of retiring, Voyager 1 kept going like an old truck that somehow decides the highway never ends. NASA extended the mission once, then again. By January 1st, 1990, the Voyager interstellar mission officially began. With a new goal far beyond the giant planets, the plan was simple to say and hard to do. Keep going until the sun's protective bubble, called the heliosphere, finally gave way to the space between stars. And back in Zone, the first surprise was where that story led. Scientists expected the edge of the heliosphere to feel like a clear border, almost like crossing a state line on a road. What Voyager 1 actually found was a messy frontier, a place of pressure, particles, and strange signals. It was less like stepping through a door and more like walking from one weather system into another. On August 25th, 2012, Voyager 1 became the first human-made object to enter interstellar space. That does not mean it left the galaxy or even left the sun's gravity. It means it crossed beyond the sun's magnetic bubble into the wider sea between stars. Think of it less as leaving town and more as finally stepping off the porch into the storm. The second finding changed everything scientists thought they might hear out there. They expected long stretches of near silence, broken only now and then by rare bursts from the sun. What Voyager 1 found was a faint, steady plasma hum, a thin note in the dark. It was like opening an empty house and realizing the refrigerator has been buzzing the whole time. In May 2021, a study in Nature Astronomy, led by Stella Koch-Acker of Cornell University, pulled that hum into focus. Her team used data from Voyager 1's plasma wave system, which is basically a way to listen to charged gas called plasma. Jim Cordes at Cornell said the interstellar medium is not truly quiet at all. It has waves, ripples, and structure, more like a restless sea than a frozen void. Scientists expected only occasional whistles from shock waves sent out by the sun. What they found was a persistent tone that tracked changes in the density of interstellar space over time. By their reading, the density around Voyager 1 rose about 40 times from 2013 to mid-2015. That is like walking from a faint mist into a thicker fog, except the fog is spread across space itself. That matters for a reason people do not always hear in quick space news clips. The farther Voyager 1 gets, the less it is just surviving and the more it is doing unique science no other probe can do. Voyager 2 is also out there, but the two craft do not carry the same path, position, and exact measurements. Lose Voyager 1, and we lose one ear pressed against a wall no one else can reach. What part of Voyager's story gets under your skin most so far? The age, the distance, or that lonely hum? And will you tell me in the comments? Your comments help me see which parts of space stories you want me to dig into next, because with Voyager, the emotion and the engineering are tangled together. And the engineering is where this story starts getting scary. In 2022, Voyager 1 gave engineers a warning that felt small at first. A system called AACS, short for Attitude Articulation and Control System, started sending garbled status reports. That system helps the spacecraft know how it is aimed. The craft still worked, but it was speaking about itself in a strange scrambled voice. Scientists expected a neat computer problem with a quick reset, and what they found was a deeper puzzle, one that took months to untangle across a delay of nearly a full day each way. It was like trying to fix a wall clock in another city by mailing it one sentence at a time. Every test was slow, and every mistake could become permanent. Then in November 2023, a worse problem hit. Voyager 1 began sending unreadable science and engineering data back to Earth. Not silence, not total death, just nonsense, alternating patterns that told the team the craft was alive but no longer speaking clearly. On April 4th, 2024, NASA said engineers had found the cause. About 3% of the memory in a computer called the Flight Data Subsystem, or FDS, had become corrupted. They suspected a single memory chip had failed, either from wear after 46 years or from a hit by an energetic particle. Imagine a cookbook where one torn page ruins the recipe every time dinner starts. Engineers expected they might have to live with the damage. What they found was a narrow path around it. They split code into pieces and moved those pieces into different parts of memory that still worked. It was like saving a family photo by cutting it apart and sliding each piece into a different safe drawer. On April 18, 2024, they sent the first relocated code. Because Voyager 1 was more than 15 billion miles away, the command took about 22 and a half hours to get there. And then Earth waited another 22 and a half hours to hear back. On April 20th, usable engineering data returned for the first time in 5 months. That was not the end of the repair. It was only proof that the old craft could still be taught a new trick. Months later, the team kept patching, checking, and protecting the software so the same kind of mistake would be less likely again. Linda Spilker at JPL called this a mission with no playbook, and she was not joking. The third discovery was not a discovery about space at all. Scientists expected the biggest danger to be the huge emptiness ahead or the dying power supply inside. What they found was a threat hiding in tiny tubes that carry fuel to the thrusters. It was like learning your house might fail, not because of the roof, but because a straw on the wall is clogging. Voyager 1 stays alive by making tiny turns. Its antenna has to stay pointed at Earth, and its star tracker has to stay locked on a guide star. To do that, small thrusters fire in short bursts. Seen from Earth, one kind of motion is a roll, like a vinyl record turning under a needle. Would you tap like and tell me why a mission like Voyager still matters to you? A like tells YouTube this story has value for viewers who care about real science, not just loud headlines. And Voyager deserves that kind of attention, because now we get to the one thing NASA truly feared. The thrusters are fed through lines, and inside those lines are even narrower tubes. NASA said the propellant inlet tubes inside the thrusters are about 25 times narrower than the outer fuel lines. Each firing leaves behind a tiny bit of residue. Over decades, that residue builds up the way grime slowly narrows a kitchen sink drain. Scientists expected those thrusters to age, of course. What they found was a slow choking problem that could pile up until a useful thruster simply could not do its job. It was like breathing through a straw that gets a little tighter every year. You can live with it for a while until one day you cannot. By 2024, the mission team was already changing how Voyager moved to save the thrusters. Commands sent in September and October let the spacecraft rotate almost 1 degree farther before correcting itself. They also began using fewer but longer firings. That is the space version of taking fewer trips to the fridge so the door opens less often. And the change sounds tiny, but tiny is the whole game now. A degree here, a pulse there, a fraction of a watt saved somewhere else. This far from Earth, survival is built from crumbs. Voyager is no longer running a sprint. It is counting grains of sand in the hourglass. But the worst piece of this story goes back even farther. In 2004, Voyager 1's primary roll thrusters stopped working after 2 small internal heaters lost power. Engineers believed the heaters were likely unfixable, so they switched to the backup roll thrusters and kept flying. At the time, that sounded fine. Kareem Badruddin, the Voyager mission manager at JPL, later said the team probably did not expect the craft to still be going 20 years later. Why worry about dead backup parts when the main mission had already lasted beyond reason? That is like tossing an old spare key in a drawer because you think you will move out long before you need it. Now, the backup roll thrusters are the ones feeling the pressure, and this is the one thing NASA warned about. Without roll control, Voyager 1 cannot keep its antenna aimed correctly or hold its star tracker on target, and if that control goes, the mission is not wounded, the mission is in real danger. Scientists expected the dead 2004 thrusters to stay dead forever. What they found was a clue that maybe the heaters were not broken in the simple way they first believed. A switch in the power circuit may have been flipped into the wrong state, and that is like finding out the lamp was never shattered, only unplugged behind the couch. The team decided to try something bold. They would attempt to wake the old roll thrusters before the active ones clogged beyond trust. But there was a terrifying catch. If the dormant thrusters fired while their heaters were still off, the result could cause a small explosion. Timing made it worse. From May 4th, 2025 through February 2026, Deep Space Station 43 in Canberra, Australia, was set to spend most of its time offline for upgrades. That dish is 70 meters wide, about 230 feet across, and it is the only deep space network antenna powerful enough to send commands to the Voyagers. So the team was racing a calendar, not just physics. They had brief contact windows in August and December, but not the steady command link they wanted. They needed the old thrusters back before the working ones failed. It was like trying to repair your furnace the day before the only tool shop in town shuts for months. On March 20th, 2025, after a signal trip of more than 23 hours, the answer came back. Within about 20 minutes, the team saw the heater temperatures rise. That meant the fix had worked. Todd Barber, the propulsion lead at JPL, called it a glorious moment, and you can hear the relief in that word. But if you know someone who loves space stories built on real stakes, will you share this video with them? Sharing helps this story reach people who would genuinely care about what Voyager is still teaching us, because the miracle save was real, and it still did not make the danger go away. Reviving the old roll thrusters bought Voyager one time. It did not give the craft youth. It did not clear every clogged line or refill every shrinking power margin. It only meant NASA had one more card in a hand already running thin. The fourth lesson was brutal because it came from power, not motion. Scientists expected the next years to be a slow, orderly shutting down of instruments according to a plan made long ago. What they found was an unexpected power drop during a routine roll maneuver on February 27, 2026. It was like watching the lights dim in your kitchen while the refrigerator and stove are both still on. Voyager 1 runs on a radioisotope thermoelectric generator. That is a device that turns heat from decaying plutonium into electricity. NASA says each Voyager loses about 4 watts of power every year. 4 watts is about the power of the small light inside a refrigerator, and even that matters now. During that February 27th maneuver, power levels fell more than expected. Engineers knew another drop could trigger fault protection, which is the spacecraft's self-defense system. If that system steps in, it starts shutting things down to protect the craft. That can save the spacecraft, but it can also create a long, risky recovery. So on April 17, 2026, NASA shut down one of Voyager 1's science instruments, the Low Energy Charged Particles Experiment, or LECP. That instrument had been running almost continuously since 1977. The team chose to turn it off before the spacecraft decided something harsher on its own. It is the difference between gently switching off a lamp and blowing a fuse in the whole room. Scientists expected science instruments to be lost one by one. Yes, what they found was that even the careful plan had to move faster because the margins had become razor thin. They kept one little LECP motor running because it uses only about half a watt. Half a watt is less than many nightlights, and in deep space it can still be worth fighting for in a skirtum. Kareem Badruddin said shutting off science is no one's preference. Of course it is not. These are the only spacecraft far enough away to sample this region directly. Every instrument that goes dark is like closing one window in the only house we have built on that street. And now comes the part scientists will tell you they do not fully understand yet. They can estimate how long the thrusters may last with new precautions. They can model power use and rehearse shutdown orders. But there is no clean chart that tells them exactly when one old part, one tiny tube, or one fading circuit will finally cross the line. NASA has even named a coming fix with a strangely cheerful nickname, the Big Bang. The idea is to swap groups of powered devices at once, turning some things off and using lower power options to keep the craft warm enough. Voyager 2 is supposed to test this first in May and June 2026. If that works, Voyager 1 could get the same treatment no sooner than July. That tells you everything about the mood of the mission. This is not routine spaceflight anymore. This is field surgery by radio, performed on a patient older than most laptops from more than 23 light hours away. It is like fixing a watch at the bottom of the ocean with oven mitts on. The fifth discovery may be the hardest one to sit with. Scientists expected a famous spacecraft to end in some grand cinematic way, maybe with silence after a final transmission. What they are actually seeing is a long negotiation with weakness. It is like watching the last candle in a house stay lit because someone keeps trimming the wick with perfect care. What do you think is the bravest part of this whole story? The engineers, the machine, or the decision to keep listening? And will you tell me in the comments? Your comments help me understand which human side of science you want more of in future videos. Because Voyager 1 is not just a machine failure story, it is a story about how far attention itself can travel. If the roll thrusters fail for good, Voyager 1 could lose the ability to keep its antenna locked on Earth. That is the nightmare behind the phrase everybody keeps using so carefully. Not instant destruction, just the slow drift of a spacecraft that can no longer hold the one pose its life depends on. And what makes that so haunting is how small the cause is. A guide star slipping off target, a heater switch in the wrong state, residue in a tube only a fraction of an inch wide, a few watts about what a bathroom nightlight might draw, deciding the fate of humanity's farthest explorer. Meanwhile, the spacecraft is still moving at roughly 35,000 to 38,000 miles per hour, depending on how you measure it. It crossed 100 astronomical units, meaning 100 times the Earth-Sun distance back in 2006. It passed into interstellar space in 2012. And in all that speed, the greatest danger right now is not motion forward, but the ability to make tiny turns. That contrast is almost too perfect. The biggest journey in human history is now being decided by the smallest motions, not giant engines, not bright fire, just gentle nudges like tapping a picture frame on the wall so it hangs straight. Voyager 1 is also carrying the golden record, greetings in 55 languages, sounds from Earth, music, and a little map of where we came from. Linda Spilker has said that even after the science mission ends, part of Voyager and part of us will keep going. That thought is beautiful, but it is also a little painful. Because right now, this craft is not only a symbol, it is still working, still measuring magnetic fields, still listening to plasma waves, still telling us what the space between stars feels like, the way a sailor tells you how rough the water is by the motion under his feet. At the start of this story, the strange image was a machine surviving by spinning in the dark. That sounded impossible, maybe even poetic in a cold way. Now you know it is literal. Voyager 1 lives by holding its orientation, by rolling, correcting, aiming, and refusing to lose sight of home. At the start, you might have expected terror to come from outside, some abyss, some unknown object, some dramatic thing waiting in interstellar night. But the real fear came from inside the machine, from age, residue, weak power, and the cost of one more turn. That flips the whole story. Voyager 1 did not reach the stars and find a monster. It reached the stars and found that endurance itself was the monster and the miracle. The same half-century that made the mission legendary also wore down the parts that keep it alive. The clock did not chase Voyager. Voyager carried the clock with it. And yet there is something deeply human in that. We do not only break because of one huge event. Often we fade because of tiny repeated efforts, small corrections, long nights, little drains nobody notices at first. A life can be changed by the cosmic and the domestic at the same time. A billion-mile journey can hinge on the equivalent of a clogged straw and a dim kitchen bulb. So when NASA says Voyager 1 is dealing with thruster clogging, power loss, and revived hardware from 2004, hear what that really means. It means people on Earth are still keeping watch over a frail messenger older than the internet, older than many cities' skylines, older than whole generations. It means every command is an act of faith delayed by almost 2 days. It means the edge of the sun's kingdom is still answering back, but more softly now. One day there will be a last useful signal. Maybe it will come after another brilliant fix. Maybe it will come after a simple failure no one can reverse. Maybe it will come quietly with no grand music at all. Just one more breath across black distance and then no next breath. But until that day, Voyager 1 is still out there, still balancing between silence and speech, still flying through a place we once imagined as empty, only to find it humming, still turning as carefully as it can, to keep one impossible thread tied between the stars and us. And maybe that is the image to carry with you after this ends, not a dead probe drifting away, not a triumph frozen in the past, but an old machine rolling by fractions, saving watts like coins in a jar, keeping its thin face pointed toward home. In a universe this large, that kind of loyalty feels almost sacred.